Okay, y'all. I just am getting used to Zoom, and so I'm going to explain the quilt pattern using Zoom. And this will hopefully help me make this transition so that y'all can get something out of this mess. Honestly, it's a mess. I might share with y'all some stuff that I've been doing Desmos, but first, this is the quilt pattern. So I go here and I'm going to click share. It's going to share my desktop. So here's the problem, right? And so you were told that the area C was 64 square inches. Now, since you know it's a square, you know that that's going to be 8 times 8. Since this area of D is 81 square inches, again, you know it's a square, so that's going to be 9 times 9. All right, so here's the 8 times 8, here's the 9 times 9, but this is a little bit teeny, tiny little square in the middle there. And, well, if this is 8 and that's 9, it's got to be 1. So that means it's 1. Well, if that's 8 and that's 1, it's got to be 7. Okay, well, if that's 8 and that's 7, well, that's got to be 15. Ooh, interesting. Well, if this is 8 and that's 1, this has got to be, well, I'm sorry, if that's 9, that's 1, this has got to be 10, so that's 10. No, it's not COVID. So that's 7, this is 1, it's got to be 6. 6 plus 4 is 10, so this is 4. And that's 10, so 10 plus 4 is 14. And that's 4, so 4 plus 14 is 18. And bingo to bingo to boo, 18, 15, 18, 14. It's not a square. All right? Okay, so I'll go here and I say stop share. And we are stopping that share. All right? Now, if I wanted to do that again, I would go ahead and let me go to Desmos. Let me show y'all what I've been working on. This is, you can probably see it, all this stuff. So I've been looking at SF, Florida, Mississippi, Tennessee, California, USA, deaths, Alabama, Kentucky. Well, if you look at SFs, this exponential is based upon Euler's function. We're going to learn that, you tricksters out there. And this right here is the model of the percentage of growth right now. And this is based upon the relation to 1. So how many cases do we know about according to the model? Divide 1 by 3.41021. That's how many cases, about 30%. So 70% of cases we don't know about, they're out there. Here's the rate of growth. So I just went ahead, and if you do an integral, you got to do integral based upon the derivative of this because it's the rate of change that you're trying to measure. And so we're looking at about 18,000 cases total in San Francisco right now. That assumes this does that. And that is this model down here. Now this model down here basically means where the middle is. So that's C. And then B is the rate of the width. So B is pretty small. This width spreads out. And that's probably what it's going to be. This is, look how small that is. That's less than 0.5. That's 0.6% roughly. And C, 42. Well, what day are we at now? Oops. We're at 36. So if things go, then we're looking at 6 days from now. I doubt that's the case because it's too early. Look at this trend. I made this other trend line. That's the red line. The red line is this. And I just went ahead and I made a graph from 1 to the end. And I found the slope. So I took this coordinate and this coordinate and subtracted, and that's how I got this slope right here. And notice that the x is 35 and the y is 37. Point slope form. How about that? And so the trend looks like adding to 29.5 per day if it's linear. Now, if it's greater than that, exponential, because it's rate of change not consistent. It's increasing. And that's what's been happening. If you look, you know, from 32 days after the 25th of February, we added 32. Here it looks like we're adding 34. Here we're adding 23, but look at what we did here. We added 37. So we're definitely above this. And so that's what this is. And if you zoom in, look at that last data point. We're going above the linear. So we're somewhere in between these two curves. I doubt this blue line is representative, but anyway. Just wanted to give this a shot, practice it, you know, do some stuff, blah, blah, blah. Y'all stay safe out there. Okay?